Welcome back, everybody. We're going to get started on Lesson 10, Part 1. This one's broken up into two parts. We're going to talk about trigonometric equations and inequalities. So let's take a look here. We have sine of x is equal to 1 over 2. And then we have the arc sine of 1/2 is equal to x. Are these two equations equivalent? Well, they're interestingly inverses, right? And they should theoretically give you the same answers because they are inverses. However, I want us to notice one specific thing. Sine of x gives you an output of 1/2. Well, it could give me an output of 1/2 at P or at Q. This here looks like it's pi over 6, which means this would be 5 pi over 6. That's what they say down here. And so sine of x means that x could be either of those. For the first one, x could be 5 pi over 6, and it could also be pi over 6. I'm going to write them like this. You'll see why in a moment. Then for equation 2 over here, wait a minute, now we're using arc sine of 1/2. An arc sine is the inverse function. Since it's an inverse function of sine, then that means that the domain is restricted. So for this one, you can only select from quadrants 1 and 4. So the solution to this would eliminate this one over here at Q. That is no longer an answer. So for this one, the only solution would be x is equal to pi over 6. So while they seem initially like they're equivalent, the arc sine has restrictions on the domain. This one, however, has no restrictions on the domain. The interesting thing is that means we need to expand our understanding of how to write our solution. Because, and it explains it right here, but for this one right here, if we want to solve sine of x is equal to 1/2, I absolutely have answers here and here, but what if I were to start in standard position, open a full 2 pi radians, and then another pi over 6? That would be one full rotation plus a little more, bringing me right back to the same point with the same outputs. So because this is periodic, it's going to keep repeating every 2 pi units. So I can add plus 2 pi, and then I'll put a k to represent the number of periods that passed. This value plus every 2 pi after that, right? This is the periodic rotation added on, indicating that there are infinitely many solutions because you'll keep hitting that point as you rotate. So this is called the general solutions. You can read through this on your own here if you'd like more information, but you can take a look here. Sine of x is equal to 1/2. This is a regular old sine, so I'll use both of these and have the period added on. Same thing here, regular cosine, no domain restriction. So take a look here. The one that gets a little bit different is tangent. Remember that a tangent function has a different period. The tangent function has a period of pi. So for this one, you're adding pi k on a tangent. So now we're on to the examples. Find all solutions for this equation. When is cosine of x equal to negative root 2 over 2? Root 2 over 2 I know is when we have pi over 4, because root 2 over 2 and root 2 over 2 on my unit circle. Actually, I'll just show my unit circle. Here we go. But then if I want it to be a negative and it's cosine, so that's the x value, the x values become negative back here. So this would be 3 pi over 4. And then every time we return to that, so plus 2 pi k. That's one solution for x. Another solution for x would be, well, because this does not have any domain restrictions, I could also come down here to 5 pi over 4 for those values, and that would make both x and y negative in that quadrant. But 5 pi over 4 plus 2 pi k, there you go. Now, this one is a sine function equal to -1. Try writing it in this general form. Go ahead, try out 2 and 3. All right, you should have done example 2. Hopefully you got this. It was equal to 3 pi over 2 plus every period repeated after that. Now, let's go to example 3. Find all solutions for this one. Since it's tangent, remember tangent is sine over cosine, change in y over change in x, because it's the slope. I want to remind you too that every single x and y has a divisor of 2, right? So I can ignore the 2's and just look at the numerator values. So when would sine over cosine 1 over root 3 would be right here at pi over 6. So that would work for pi over 6. Does that make sense? And then we need to make sure that we include the period here. So the period would be every pi times k, because the period is 1 pi. And I want to show you something. 1 pi would bring us down here to 7 pi over 6, which in this case is negative root 3 over 2, comma negative 1/2. So 1 pi later, same exact values, except the only difference is the double negative, which makes it positive again, which gives us the same value. And then another pi brings us back to here, then back to there, then back to here. So those will keep repeating. Now we're going to make these a little more complicated. There's some series of steps here that you can read through that can kind of guide you through how to do these. The idea is to use inverse operations to isolate the function. So looking at this, we got 6 times the sine of theta is equal to 3 root 2. Inverse operations, I'll divide by 6. That leaves me with sine of theta is equal to 3 over 6 can reduce to root 2 over 2. And then when is sine of theta equal to root 2 over 2? Well, let's check that out. On your unit circle, you should recognize that that's a pi over 4. And then since it's sine, that is the y value, and y has to be positive in this case. So the y values are positive in quadrant 1 and 2. So that would also include 3 pi. I'm going to write it vertically. That would also include 3 pi over 4, because the positives on there, and then we're going to put 2 pi k because these are going to repeat for the period. So both of those are potential answers for theta. Let's look at this one. It gets a little more complicated. Again, I want you to take these. Let's set it up. It says 3 plus 2 cosine x, and I'll set it equal to 2. I'm going to subtract the 3, right? Just like any other two-step equation, this is now -1. Then you divide, and I end up with cosine of x is equal to -1/2. Think back to your unit circle. When is cosine, or the x value, equal to a -1/2? Well, in first quadrant, cosine is 1/2 at pi over 3. But that becomes negative, so that's either at 2 pi over 3 or 4 pi over 3 in the second and third quadrants. So then that means x is equal to 2 pi over 3 and 4 pi over 3. Now, I normally want to make sure that I write my general form, right? Plus 2 pi k. but they restricted the domain on this one. So we only have these answers because we're not going to go back around the unit circle more than once because they want theta to be equal, or sorry, in between 0 and 2 pi. So I'm not going to have an angle that exceeds 1 rotation. Great. Now, on the next page, we are going to get some that get a little more complicated, so we're going to have to include some square roots here. Go ahead, take a moment to read through this. So now that you've hopefully read this notation, you'll understand both the value of this notation and how it helps us make sure we see the difference between sine of x squared versus sine squared of x. Let's go to example 6. We've got this function right here, and it wants to know what are the zeros of g on this interval. So I'll say 0 is equal to 3 minus 4 sine squared of x. Wait, zeros? Aren't those for quadratics? Well, let's see what happens. Subtract 3, subtract 3. We end up with negative 3 is equal to negative 4 sine squared of x. Now I'm going to divide by negative 4 on both sides. Sine squared of x is equal to negative 3 over 4 becomes 3/4. Now from here, what would we need to do to get rid of a sign that's squared? Well, you get rid of it by doing the square root on both sides. That leaves us with the sine of x is equal to a positive and a negative root 3 over 2. So now we need to find all the times that sine is either a positive root 3 over 2 or negative root 3 over 2. Going to your unit circle, you should recognize that that's going to happen 3 times. That'll happen at sine pi over 3, 3 pi, so pi over 3, 2 pi over 3, then again down here at 4 pi over 3, and then again at 5 pi over 3. And then it does restrict my interval right here, so I don't need to have any sort of repetition. I don't need to put any sort of general rule there. Go ahead now and take a look at example 7. We've got cosine squared of theta is equal to a negative cosine of theta. Now, I do not want this to be on both sides, so I'm going to bring cosine of theta over using addition. So I have cosine squared of theta plus cosine of theta is equal to 0. Hey, guess what? We essentially have a very basic quadratic here. This is like having x squared plus x equals 0, and instead of x, we have cosines. Now, if you were to do this, you would take out the greatest common factor. So I'll do that here. Cosine of theta divides out. That leaves me with cosine of theta plus 1 is equal to 0. And now we have different solutions here. We take the left side, cosine of theta, set it equal to 0. When is cosine of theta equal to 0? Well, go to your unit circle. You'll find that that is going to be at pi over 2 and 3 pi over 2 for your theta. Now, I also want to do the other equation. Cosine theta is equal to negative 1. When do we get a negative 1 for the x value? Well, you should recognize that one as theta equals pi. So here we go. We got our three answers, pi over 2, 3 pi over 2, and pi. I do not need to put a general form. I don't have any repeating values because it restricted my domain for me. All right. This one's going to get a little more complicated still. So I would love for you to try out example 8 here. It's a little more difficult, but I think you can handle it. All right, my hope is that you were able to get the root 3 sine x over using subtraction, then divide out a greatest common factor. My hope is that then you can take the two factors, sine of x equals 0, and figure out the values. Sine is equal to 0 when x is equal to 0 and pi radians. The second one looks a little more complicated, but it's not too bad. You would say 2 sine of x minus root 3 is equal to 0. Add root 3 to both sides. You get 2 sine of x equals root 3. Divide by 2, and you find that sine of x is equal to root 3 over 2. Root 3 over 2 for your y value happens a couple of times. It happens at pi over 3, and then again at 2 pi over 3. Do I put a 2 pi k? No, I do not, because it is already given. So here we go. We got 4 possible solutions for this equation. Here they are. All right. If you do have questions, come to class to ask them. I personally think these are kind of fun. I hope you do too. Nerds. See you guys.